Give me a... Okay, so like, this is the number 19 on the test, so meant to be challenging for sure, right? So, but before we get started, we are given equilateral triangle, which is like this guy, and we are given 3 congruent trapezoids. So that is another information we have. So they are all equal to each other. And what we have is the side of the inner triangle is a third of the larger triangle. Okay, so if this is like 2x, that means this is 3x. So the ratio is 2 to 3. That's what we are given. But before we try something, maybe it's good to remember something about the similar triangles area ratio. So if you have 2 triangles are similar, so actually let me kind of remind them. So if you have 2 triangles are similar, let's say this is similar to this guy. Okay, and I'm gonna say, let's say this is A, and I'm gonna make a similar figure to this guy. So this is similar to this one. Let's assume these 2 are similar. If you have 2 figures are similar, they are proportional, meaning that every side, corresponding sides are like in the same ratio, and they are in same proportion. So if I, let's say, multiply this side by some number, let's say this is k, I'm gonna call this is A times k. Okay, so I'll just find the relation between the area of the 2 similar triangles. Okay, so if you think this is like my altitude of the smaller one, let's say this is h. Okay, since we multiply this side by k to get another similar figure, so I need to multiply the height by k as well. So that means this is gonna be A times k times, actually, h times k. So otherwise they wouldn't be similar. So what I'm trying to do, I'm trying to find 2 similar triangles so I can kind of see how their areas related. So if I name this is A, B, C, this is called A prime, B prime, and C prime. So the area ratio, A prime, B prime, C prime, divided by ABC. Okay, so again, we multiply each side by the k. K is just the ratio of the similarity, basically. You just scale that triangle by k, another way of to say. So the area of this triangle is the base times height. So the base is just AK, and the height is HK, and this divided by 2. And if you do the same thing with the other guy, so that will be the base is A, height is H, divided by 2. So since 2's will cancel each other, that will be easier to get rid of. And then A's will cancel, H's will cancel. So you got K times K, which is K squared, divided by 1. That means that K squared. So look at this guy. This is actually one of the things that we have to remember always. Whenever we have 2 figures are similar, which is like those 2 triangles, the ratio of the area is actually square of the ratio of that scale, basically. Okay, this is gonna be useful. So if you know the ratio of the sides or ratio of the similarity of 2 figures, it doesn't have to be just triangle. It could be any shape. Then area ratio is gonna be k squared. The reason why it's just k squared, because you are scaling every side. And then if you are dealing with the area, that's just a 2D. So that means 2 sides is gonna be scaled by that k. So the area ratio has to be k times k, which is k squared. So this is something we have to use, and then I'm gonna use this in every similar triangles if they have somehow area ratios given. So we are told this is 2, this is 3, but before we move on to this idea, this is equilateral triangle, and the larger one is also equilateral triangle, meaning that they are similar, because all 3 angles are equal in those 2 equilateral triangles, so which is why they are similar. and the ratio is 3/2. So the ratio of 3/2, this is my scale basically. If you square this guy, you should be getting 9/4. What does that mean? So 9 is the area of the larger triangle, 4 is the area of the smaller triangle, okay, as the ratio. So then how this is going to look like? If I want to name this area, the smaller triangle is like 4 times something. Let's say this is 4A. And then the total has to be 9A, but the 4 is right here. So that what's left over is 5A. So 5A basically this plus this plus this. So you have 3 equilateral, three of the identical trapezoid because that's congruent trapezoid. So in those 3 is 5A. And then if you divide by 3, so you will get the shaded region. Okay, so shaded region. And we are looking for the area of the trapezoid to the area of the inner triangle. So the area of the trapezoid is this guy, 5A over 3. And then we want to divide this by area of the inner triangle, which is 4A. So the A's will cancel. 5/3 divided by 4. So I can just write as over 1. So 5A over 3 times. So you flip this guy. So that will be 1/4A. So the A's will cancel. You got 5/12. And that is the final answer. So it took a little bit longer for me to do this problem. The reason why it took that longer, because I just need to explain this guy. So which is why it was a bit longer. But if you had this idea already, then you can just do the 3 half squares 9/4, and then as soon as you have this is 4, the whole thing is 9. That means those 3 congruent trapezoids should add up to 5A. So that is 5/3 divided by 4 is just 5/12. So you can do this problem less than 20 seconds if you really kind of get that whole idea. So that would be the answer. So we are told AE is 1, this is 1, this is 2, and then there is a point D right here such that DE and BC is parallel. So this guy and this guy is parallel, and there is a point F right here so that EF is AC is parallel. Okay, so these guys are parallel, and the area ratio of the CDEF, which is basically this parallelogram, to area of the ABC. So there are maybe like a few like different approaches to do so. Since we are interested in the ratio of the areas, maybe it's better to use somehow similar triangles as well. So, but before we move on, maybe we should say that, you know, if I have this is parallel to this guy, so the angle at B, so this angle right here, and the angle at E has to be corresponding angles. Those two angles are congruent to each other. And the same idea, if you look at the angle right here, okay, so let me change the color. So the angle at C is actually same as this angle. The reason why they are equal, because these two are parallel, so, and then the angle right here are corresponding, so they has to be congruent. So why this is important? Because right now I see this is a triangle, and then the larger one is also another triangle, and then they have 2 pairs of angles already. And then angle A is common in this triangle and this one, so they have 3 same angles. If you have 2 same angles already, that means they are similar, right? If you know the similarity, so the ratio of the similarity, you know, this guy, if you look at the actual larger one, so the larger one, the blue angle is opposite to 3, okay? And in the smaller triangle, the blue angle is opposite to 1. So this is the ratio of the similarity. So that's basically the ratio of the similarity. But if you square this, you will get the area ratios. Okay, so which would be like ABC divided by like AED. So that's gonna be 9/1 basically. Okay, let's keep this in mind. And another one that we have, since AC and EF is parallel, so then you can say this angle and this angle are equal with the similar reasoning, and then this angle and this angle are equal because these are parallel. So meaning that this triangle right here and CAB are also similar. So if they are similar, we can write the ratio again. So in the larger triangle, this angle, which is the same as my purple, but maybe I should use the same color. Maybe that would be same as this guy, but it's fine. So this angle C is opposite to 3, okay? And the same angle is right here opposite to 2, which means the ratio is 3/2. But that is the ratio of the similarity. If you square that, you will get 9/4, which is going to be equal to area of the ABC divided by, so ABC is similar to EBF. Okay, so I hope that makes sense so far because this is kind of similar to the other one. Okay, so then, ABC corresponds to 9, EED corresponds to 1. Maybe we can just write those. So if I call this area is A, then the whole thing will be 9A. So if the whole thing is 9A, so that means EBF will be 4A. So that will be 4A. And the total is 5, so the remaining has to be 4A. So that should be 4, 4, 1, which is 9 in total. So the area of the CDF is 4, okay, divided by ABC. ABC whole thing was 9. So that looks like my answer, which is our choice A. Okay, so again, it is not too challenging, to be honest, even though this was number 20. So the only thing that we use just the area of the similar triangles ratios, okay? That relation is important. But at the same time, knowing those two triangles are similar is actually a bit complicated. But whenever you see some parallel lines, that will be your basically hint, okay? The question says like the triangle XYZ, the whole figure is 8 square inches, okay? And A and B are the midpoints of the side, so that means this piece and this piece are equal, and then XB and BZ are also equal. Since we don't know XY and XZ, like maybe they are not the same size, so which is why we cannot just say this is the same as this one. So we know only B is the midpoint, A is the midpoint. And also we are given a XC, which is this guy, is the altitude, which means that's my height. And then that height bisect the YZ. What does that mean? Bisect means divides into 2 equal pieces, which is actually nicer. So that is like this piece is the same as this piece. So when you have a altitude is actually at the same time dividing the side into 2 equal pieces, that means this is my median. Okay, so if this is a median, you can tell the same segment is also angle bisector. So meaning that the angle right here and the angle right here is equal, but we may not need that for this problem. And then based on that area of the shaded region. Okay, so, if the whole region is like 8 units, that means the half of the triangle has to be this piece, and the other half should be this piece, which is like 4 right here, 4 right here. That is something we know. And since this is midpoint and this is midpoint, then I can say AB and YZ is parallel. So if you are not sure why that makes them parallel, so it's just the similarity, because we have this divided by this is 1/2. This divided by this is also 1/2, which is 2 sides are proportional, and the angle in between, which is x, is equal in this smaller triangle and the larger one. Since we have 2 sides are proportional and the angle in between are equal, we call that they are similar by side angle side. So since they are similar, AB and YZ has to be corresponding sides, which is going to be 1/2 ratio as well. But that is something we know, and also we know this guy is parallel to this guy, because when the smaller triangle and the larger one is similar, the corresponding angle A and corresponding angles Y is equal, angle B and angle Z is equal. Since those are equal, then that will make these two parallel. Otherwise, they shouldn't be equal to each other. But anyway, that's a long story. So basically, since this is a midpoint and midpoint, AB and YZ is parallel, okay? So that is something we know. But if this is parallel, that is also mean this smaller triangle and the larger triangle are similar. Or this XAB and XYZ is also similar. So why this is important? Because if you look at this side ratio, this is 1 unit, and then this is 2 units, right? Because that was the halfway through. So the ratio of XY divided by XA is 2/1. But we already know when you have two figures are similar, the area ratio was the square of the K. That's the similarity ratio. So if you square this one, that will be 4/1. So that means the whole region will be 4 unit as area, unit square. Then the smaller one will be just 1. Since we know the whole thing was 8, so that means the half was 4. And then this is 4, that make this guy as just 1. This is gonna be 1, and then what's left over is 3, and that's the 3. And then you can say this is also 1, and this is also 3. So you can kind of guess it if you like, but the area is 3. So this is one way to do this problem, if you like to use the similar triangles. But there is something a bit better than this, especially for this case, that we could have done instead of doing this way. So what else we can do is basically, we can use somehow this figure. I can connect A and C, and then I can drop this altitude. So we know this is same as this one. Okay, so that will make it, this is same as this guy. And since this area and this area equals, since this side, like the bases are the same, so if you take this altitude, so this region is 1A, that will make this guy 1A as well. And then since this is gonna be our rectangle, we know this is 90 degrees, so that is 90. And then since this is parallel to this as well, so that's also 90. So that will make this region to be A. And then this triangle has this piece and this piece equal. So if this is A, that means this is also A. So as you see, we have 4 of these A's, and 3/4 of the whole triangle on the left is actually the shaded. So we know this was 4, 3/4 will be just 3. So you can go with it as well. But I think this is something we can use, especially when you have some nicer picture. So that was number 20. So you can use, I guess, either way. The M and N are the midpoints, right? So this is same as this one, and this is same as this one, right? And when you have this is same as this one, this is same as this one, so which is we actually saw in one of the previous problem, actually in 2 different questions. So the MN and AB will be parallel as well. The reason why they are parallel is because PMN and PAB will be similar by side angle side, because 2 sides will be proportional 1:2 ratio, and the angle P in both triangles are same. So they are similar. Since that's similar, the corresponding angle MA will be equal and B will be equal, which will force MN to be parallel to AB. So again, whenever you have the midpoints, it's easier to think that that is parallel to this guy. So that's something we have already. And if that is parallel, you know, this triangle and this triangle are also parallel, so you can go back, but let's keep that in mind. So the part A, if you drag this point P on this line, which is parallel to AB, meaning that this line is parallel to this MN, that's parallel to AB. So they are, all 3 are parallel. If you drag this P to the left or to the right, so the length segment MN. So the MN is actually half of AB, because the ratio of MP to PA is 1:2. So they are similar triangles, MN and MAB is corresponding parts. So the ratio is 1 to 2. Since AB doesn't change, MN doesn't change as well. Regardless of where you drag this point P, if you drag it here, so this MN still will be half of AB. So that's why that doesn't change. Okay, so the perimeter of PAB, since we didn't change the size at all, actually, let me see, PAB, actually we do change the perimeter of the AB, because even though we don't change the AB, but if you drag this like, I don't know, maybe all the way to the here, so let me kind of visualize a bit. So if you don't really kind of convince yourself, you can just take a, let's say, point P right here, right? So if you drag that point P all the way to the here and all the way to the here, so if that's your point P, I'm gonna call P prime. So as you see, this distance right here is, this distance is way different from the other two. So which is why this will actually change. Okay, so it might be way bigger, it might be a bit smaller, depends on where you actually drag that point P. But for the area of the PAB, you know, even though you drag all the way to here, the distance between this line and this line, which will be our height, so this height will not change, regardless of where you drag that point P, the height for a side AB will not change. Height is not changing, the AB as a base doesn't really change either, so which is why the area doesn't change either. So the area will still be same, which is really nice because sometimes if you have two triangles share the same height and the same base, then you can tell they are actually having the same area. Okay, so in this case, P prime AB and PAB has the same height and the same base, so they have still the same area, doesn't change. The area of the trapezoid A, B, and M, which is the area of this trapezoid, since we actually don't change the area of the triangle when you drag it to the left or to the right, the reason why it doesn't change, because the base AB didn't really change, right? And the height didn't change either. So, which is why the area of the trapezoid doesn't change either. So we are looking for the ones that is changing. So only one thing is changing, which is B. Okay. So the question was asking how many of these actually change, which is only one. Okay, so that was actually a nice question to test the similarity background as well. So this is actually way easier than the other ones. So let's think about a bit. So if you look at the problem, it says rectangles, right? Screens are actually what we use to call their the size, and then we are told the ratio of the horizontal and the length to the height is given 4 to 3. So let's kind of visualize to see how that looks like. So let's say this is my rectangle. So this is 4 and 3, right? Those are actually the ratio. So I'm gonna call 4x and 3x. And horizontal length of 27-inch television screen is given. And what would be, actually no. It says the horizontal length to the height in that screen is given 43, right? And then horizontal length of a 27-inch. Okay, so how do we name this TV, right? It says 27-inch, but is this 27? Is this still 27? We use the diagonal to name it. So, for example, if you want to name this TV, so you are going to need to know this distance because that will determine the size of the TV. So if you remember the Pythagorean, so you know 3 squared, 4 squared, that's 9 and 16, which is 25. So that will be 5 squared. So that will be 5x because we don't know actual value. So if this is my TV, that means the name of this TV, size of this TV will be 5x inches. So, okay. So we are told 27-inch is the TV. So the ratio of 5 to 4, 5 to 3 has to be same in the given problem. So we are looking for the horizontal length, right? So horizontal length was 4 once, which is this guy. So the 5/4, the ratio doesn't change when you make the TV bigger or smaller, okay? So we are told this guy will be 27. So that should be 27 over question mark, which is my horizontal length, basically. So if I'm going to name it this horizontal, if you do cross multiplication, so that would be 4 times 27, 5 times 8. And this is a nice number because it's 5, so you can just multiply by 2 to make it 10. So the H is twice of this 2754, twice will be 108, 108 over 5. If you double these numbers, then we will get 216 over 5, over 10, and that will be 21.6. So this is exactly 21.6, but since this is closer to 22, so I should be going with, actually no, we have some fractions as well. Since we have like 21.5, so I was expecting the integer, but it's not. So this is 21.6, but the closest number of these choices is 21.5, okay? So that would be the answer. So only thing that we use in this question is just the ratio has to be same because you are making similar shapes, similar rectangle. But that wasn't. Whenever you see some parallel lines or 90 degrees, hunt for similar figures, similar triangles. And then this is one of the common shapes that you will see it because DC and AB are parallel. Since that's a square, the opposite sides are parallel to each other. And that will tell you, actually we don't need to have that because this is already square. If this wasn't square, let's say this was a rectangle, you could still have that. The angle right here and the angle right here has to be the same because I'm not sure if you know this guy. When you have two parallel lines, okay, so let's say this is the third line passing through those two parallel. So if you have this shape, some people call Z rule, but if you look at this guy, the angle in between that Z is called alternate interior angle. So when you have two lines are parallel, the angle in between those two Z part is called alternate interior angles, which are congruent as well. So which is why the angle A and angle C, part of this C, part of A has to be same because we have a Z right here as well. And a similar reasoning, the angle right here and the angle right here is also equal, the same reasoning. And that means this triangle and this triangle are similar since we already have two angles. And the third one right here and the third one right here is called vertical angle. So we already know the two other angles were congruent, so that has to be congruent as well, okay? But now we have two figures where have the same angle measure, so we mean that they are similar. But let's look at what other information we have. E is the midpoint, okay? So that means if I name this as X, that will be X as well. Since this was given as a square, so which will force to be 2X and 2X, okay? And then AFED, this region is given 45. And then based on, okay, so what we are looking for just the whole region. So we know the area of this region. This triangle actually and this triangle are similar, and the ratio is 2x over 1x. So 2x over 1x is 2 over 1. So that was my K, which is the ratio of the similarity. But if you are considering their areas, that should be squared, meaning that if I know the area of this region is like 1A, and then that means this is going to be 4A, because that should be squared to get the area ratios. We proved already, okay? And that is something, but at the same time, the ratio was 1 to 2, right? So the red angle is opposite to EF in this smaller triangle, the red angle is opposite to BF, which means that ratio is also 1 to 2. So if I call this is K, let me use different color. So if I call this is K unit, the EF, so which will force this to be 2K. So why this is important? Because I'm going to use the side ratio to find the area. So if you look at the angle C, the corner C, the vertex C, and this triangle with the base K, and then this BFC, the triangle with the base 2K, is actually sharing same vertex. Meaning that when you drop the altitude from this C to this side, okay, let's assume there will be height right here. So the altitude of this triangle and then this triangle will be the altitude will be same since the sides are 1 to 2 ratio, and I do know the area is base times height over 2. So only thing is just double is this side. So that will make the area doubling as well. So if that doesn't really make sense, maybe it's good to review a bit more as well. The area ratio of the two figures where you have one corner is the same and you can just compare their size. So another way to remind, maybe like this, just to kind of see how that looks like. When you have a triangle, let's say these three triangles are sharing the same vertex. Okay. So since the corner A is the same, so if you drop the altitude from A to BE, that height will be height for all of those triangles. So let's say this is 1, this is 3, and let's say this is 7. So that area, if this is 1A, that will be 3A, and that will be 7A. And if you are not really convinced with this ratio, then maybe I'll ask you to review some of the other videos, okay? But I will say if the sides are like, if the corners are the same and the base are different, like numbers, like ratios, then the area ratio is the same as those base ratios, okay? So for that reason, the C is the corner, so this is K and this is 2K. If this is 1A, right, that will force this region as area is 2A. Because this is 2K to 1K, so that should be 2A to 1A. Again, these two triangles are not dissimilar. So if you are confused why we are not squaring, because this triangle right here and this triangle right here is not similar. Similar ones is this guy and this guy. So that's why the ratio was 1 to 2 for the sides, but the area ratio was 1 to 4. So that is different case. So now we know the area of the ABC is 4 plus 2, which is 6A. That will make ADCs also 6A. One of them is right here, so what's left over is 5A. And you are basically done with this. We are told this is equal to 45. Okay, so that means A has to be 9. If A is 9, the whole thing was 6 plus 6, which is 12A. So 12A is actually 100A. And that is my answer. So even though the square was the question, but the area is not actually a perfect square because the side doesn't have to be integer. Yeah, that was number 22, as you see, so which meant to be challenging. So that was the case. So we could try this question a couple different ways, but my focus is just the similar figures. So that's why I used that. Another question that can be done at least 4 or 5 different ways by using different skills. But my focus is just the similar figures. You know, we've seen like this figure before. Whenever you have this type of triangles, so that triangle right here and this triangle right here are similar. And since we know this is 3, so that is also 3. And the ratio is 1 over 3. So if that's the case, you know, the angle B, so this corner is the same as this angle. So the opposite side is this piece. If I call this is K, and the opposite side in the other triangle will be 3K. So because this small one and this larger triangles are similar. So that is good to know. And if I wanna maybe name this area as A, so since this is K to 3K and then they share the same vertex, so this area is gonna be 3A. Okay, so that is something, but I'd like you to look at something different now. So look at this triangle. So this triangle that is red one is the, if you want to really find the area of this triangle, you are going to multiply this space. But if you need to drop the altitude like this, that altitude will be 4. So that means 4 times 3 over 2, which is actually 6, right? So we actually know A and 3A. So let me just say one more time. If you drop the altitude from C to, let me use different color. If you want to drop the altitude from C to EF, so this is going to be my altitude. But this altitude is the same as the E, that's the same as the 4. So that is 4, this is 3. So the area of this triangle will be 4 times 3 over 2, which is 6. So that is going to be total 4A. So if you divide by 4, so A has to be 3 over 2. But this region and this region will be same. They are just basically reflect over this point. But if you don't really see it, you can just think about it this way. So BEF, right? BEF is also same triangle as this one in terms of the area. Why? Because if you drop the altitude from B to EF, that altitude will be same as this altitude. They have the same base. Since their height and the base are the same, so the area is the same. So, and then this region is 3A, and this has to be 1A as well. So this is really nice to see because whenever you have parallel lines, that will be the case as well. So these two regions will be equal to each other. Since we know A is 3 over 2, so we have 2 copies of that. So that should be 3 as our final answer. So you can try this question a couple different ways, but I think this is also not too bad. As you see, this is number 22, but the work that I did is not much actually. And that was the answer. Problem that we start with, and then some other question we already did as well. So when you have two similar triangles, the area ratio was the square of that like scale basically. So, and we are told B to B and then AC is actually parallel because we are told these are isosceles triangle and AC is parallel to the top one. Okay, so they are the same triangle, so the height will be same for both. So meaning that we are also told, right? So the segments are drawn parallel to AC, which means this is parallel, this one, and so this one and this one is parallel. So this one and that one is parallel. So meaning that this white triangle and this whole region, and then this region, gray region and the ABC are similar. So that is the key. So we have two figures are given, and both triangles are similar. So let's write the ratio. If they are similar, the ratio of the every part has to be equal. They has to be proportional. So the 11 divided by the altitude of the larger one is going to be this height. So that would be h. And this is the ratio of 11 to the larger height. And then this, when you square it, you will get 121 over h squared. Why did I square? Because whenever you have two figures are scaled by something, which is 11 over h in our case, you need to square that scale to write the ratio of the areas. So meaning that if you know this region as 121, that means the whole region will be h squared, whatever that number would be. Okay, but we don't really know, and then we are told this region and this region is the same. So since we know the ratio, I'm gonna call this region as like 121. Actually, let me call this as 121A as area. And the area of the ABC has to be h squared times A. But if you wanna find this shaded region, so that should be h squared A minus 121A. So that will be like 121A. So I'm not sure if this makes sense. Like this is basically what I did. Since area ratio is 121 over h squared, if I call this is like 121a, because that's not the actual number, just the ratio. And this could be written as a squared times a, but this region is the area of the whole region, not just the shaded one. So then if you want to find the shaded region, so that's the whole region, you need to subtract that to get that shaded piece. So that is something, and then I will do the same thing with this guy. Since we know this is 5, and the whole thing is, if you kind of connect B to this, that will be h minus 5, so this distance. Why do I need? Because I need the area of the shaded region. So the ratio of those two triangles, I mean the height, is h minus 5 over h, because the whole distance was h. And if you square this, you will get the area ratios of this triangle to the larger one. But look at the expansion. So you got h minus 5 to the second power over h squared. So if you remember, this was h squared was the whole region. Now we got the same thing. So the numerator, so if you want to go with the area, so then since we have the same denominator, so that means the numerator h minus 5 squared has to be area of this region. So let me say this is going to be h minus 5 to the second power. But this is just the ratio, so maybe I can just multiply this by a as well, because denominator will be a squared times a as well, which is really nice. So now we know this region and this region has to be same, and then they both multiply by the same a, so which is why we can actually cancel those. So the a squared minus 121 times a equals h minus 5 squared times a, so a's will cancel if you divide both by a, so that will be just the ratio, and h minus 5 to the second power. And then if you expand this guy, so h minus 5 squared, so let me do that right here. If you know the square of binomial, you can just use that to make it faster. But if you don't, you can just write it like twice and multiply h by h will be h squared. H by negative 5 is minus 5h, and then this guy time this will be minus 5 as well. Negative 5 is 25. So that would be h squared, and then you got negative 2, 5h's, which is negative 10h, plus 25. And h squared minus 121. So these guys will cancel, which is really nice because we don't have to deal with the quadratic, basically. And you may add 10h to both sides, so you will get 10h equals, subtract, add 121 to both sides, so you will get 25 plus 121, so 10h of 146. And then this is a really nice number because we are not allowed to use a calculator, so it's divided by 10 is easier, so that's 14.6. So when I did all the work, as you see, that was actually my choice, which is good, and that is the answer. Like, this is, to be honest, a bit challenging, especially it has some sort of like algebra involved, but the overall idea is actually the same. So when you discover figures are similar, and then if you are looking for somehow area relation, then just remember area is basically, area ratio is the square of the scale. So that is the whole thing I just used as a main, I guess, step. And that is just help. So this is number 24, which is nice question, actually. When the side AC, like this side, is given in the ratio of AD to DC is 1 to 2. So if this is K, that will be 2K, basically. And E is the midpoint of BD. So let's write that guy. And F is the point of intersection of BC and AE, okay. And the whole region is given 360, and EBF is what we are looking for, so which is this region. Okay, so like this question actually can be done at least 10 different ways by using different approaches. But I will just try to see if I can do some similar triangles, but there's no parallel line, right? There's no 90 degrees either. which doesn't look like we have similar triangles in those cases then, but we may actually have parallel lines if you actually draw yourself. So you can get something what you want. So what I'm gonna do, draw a line from point D to AF in a way that that line segment is gonna be parallel to BC. So why this is important? Why do I care? Because I do know the ratio of this to that, and then that is the midpoint. So that is kind of good to see some different or similar triangles. So if I call this is T, so this is parallel to this guy, okay? So, whenever you have parallel thingies, the zero, so the angle D is the same as B, angle F is the same as this T, so which means this is similar to this one. That is good to know. And the ratio is, this is same as this one, which means if I call this is like A, then TD is also A, because the ratio is 1 to 1, so that will be the same. So if I call TE as B, so that means EF should be B as well, because that is also 1 to 1 ratio. Okay, so that is something. But what else we have? So we have also, ATD, let me write that. ATD is similar to, this triangle ATD is similar to AFC. AFC. Why this is similar? Because the angle T right here is the same as F right here. So this angle part of D is equal to the same as this one, just because these two are parallel line. So which will make the ratio are the same. So the AD is the side in the smaller triangle, and the larger triangle AFC, the side is 3K, which is 1 to 3 ratio. So if you have 1 to 3 ratio, it has to be same for all the sides. So, AT divided by AF, those are the corresponding side, has to be 1 to 3 as well. That is why AT has to be B as well. Why this is the B? Because that is 1, the whole thing has to be 3, because we already know K to 3K was the ratio for the ATD and AFC, or some people may know AD divided by DC is 1 to 2. So this divided by TF is also 1 to 2. So we already know TF was 2B. That means this is going to be 1B. So you could go either way. But why do we need to care about the ratios? Because whenever you know the sides ratios, that will give us some area relation. That is why we need that. Okay. So what I'm going to do, I can start with this region as A, because that is what I need, right? And this triangle and this triangle were actually identical. So that means these areas will be same. And I do know this triangle and ATD is also same, because this and this, the base are the same, and they share the same vertex. So that means this is also A. So we know at least those so far. What else do we know? We can do a couple other things. We said area of the ATD, the triangle ATD, which this guy is similar to AFC, and the ratio was 1 over 3. So if you square this, you will get 1 over 9, which means if this is 1A, the whole AFC has to be 9A. So if you take these two, so that will be 7A for this remaining region, which is also useful. But we have one more thing missing, which is ABE. And if you think as like this B as your common vertex, so this triangle has side B, and then ABE has side 2B. So which means the ratio of this side to AE is 1 to 2. That means area ratio is also 1 to 2. So that's gonna be 1 to 2A. But this is one of the good questions that you are actually seeing the difference between the area relation compared to similarities, like similar triangles area relation, and area relation with the base ratios. So they are two different things, okay? So again, the triangle BFE and ABE are not similar. They are just sharing one common vertex, meaning that they have the same altitude, same height. So the base ratio will be their area ratio. But if you have similar figures like this one, so then you are going to say the area ratio will be square of the scale, or ATD and AFC were also similar, so area relation will be square of the scale, so which is why we did square. So now we have everything, so that's 3A, and then this whole thing was 9, so in total is 12. A is given 360, divide by 12, and that will be the answer. And that's B. So you could do these questions a lot of different ways, but this is not too bad, especially for number 20, number 24, okay?